Hello everyone, today's presentation is about my project where I try to integrate RPi4B and Max-E2 together, and today we'll talk about the mechanical aspects only for this project. Topics are, first one is about the ROBOTIS slim case to contain the RPi4B. We'll talk about that. I show you my solution how to add a Pi camera to a Pentium platform for the head of the Max-E2. I'll show you again how I use wire UART between the RPi4B and the CM-550, and then lastly about my solution for sharing the LiPo battery between the CM-550 and the RPi4B. So first, ROBOTIS recently received a slim case. That means it's light possible for the RPi4B. So you can see the website from Tinkercad here. This is for this one, for the one I use in this project. Now when you go that side, you can see that they have a slightly changed version here also. So you can pick up the one you want to use. So you can see the this version here, the one I'm using, you have two components. Basically the bottom part, you see lots of rivets hole. You probably guessed it already. It will be mounted using the 6mm rivet from ROBOTIS, and then it's a cover. Okay, so the RPi4B essentially is just slit in there and then screw down, and the top cover go on top. So first, I want to put it on top of the top side, on the top side of the CM-550, which unfortunately doesn't have enough, lots of rivet holes. So I have to install a layer of plates for the trim of the mini part, so that I can get more rivet holes. Okay, so why I need to that? Once I have this layer that plate down on top of the CM-550, and then you can see I have plenty of rivet holes so that I can mount the actual bottom of the slim case for the RPi4B. So we'll be using 6mm rivets. So you may have some of these already from your dream or mini parts. Then once you've done that, you slit the RPi4B in, and then you just secure them using 4 screws, as you know, in any other case that you probably find out on the market. And then on top of the cover, I need to use a fan because it's going to get hot in here. So for the fan, I just use double-sided tape, and I tape it around top of the cover piece. Okay, and then you put the cover back on, and then they also secure using 4 6mm rivets. And then, you know, I tap in the power. So that's roughly what it looked like. You probably noticed the camera ribbon coming out into the head. So that's where we're going to talk next, about the neck and the head with the Pi camera inside. So the neck can do pen tilt. Let's see. So first, actually, when I started this project, I was trying to follow the hardware that was used in the Kit 2, where essentially they give you an SM10. I just buy another SM10 and I can do pen tilt with the camera, Pi camera mounted inside the headpiece. But as it turned out, these guys are very unreliable. That means that the value changed very quickly for some no reason, and it's not reliable enough. So I have to scratch this project and actually put an actual 2XL 430 as the neck part component of the robot. Okay, so we'll go into the detail what I need to do to get that job done. So let's first talk about the Pi camera, how it's mounted. So the Pi camera, either you buy yourself or you get it from the Kit 2. Except we need to buy another thing. You need to buy I call the blue cable, but it's a full width cable because we'll be interfacing with the RPi4B, not with the RPi0. So the cable that comes with Kit 2 will not work for us in this particular project. You need to spend some money. It's pretty cheap to get a blue cable here. So once I got my Pi camera mounted in the headpiece, and then I use the dummy XL330 from the kit one, so I just mounted it there to serve, so we say, just like the jaw area or the bottom of the neck, shall we say. And then I put in some dual lock tape in there. So that will go onto the Pentail servo platform that I'm going to show next. Okay. So to set up the Pentail platform, I use another 2XL430, but I already built my robot. So had to go in and do some serious reconstruction. So the body part, shall we say, or the torso part, I had to remove the front half of it out, and because that part actually have the two arms connected inside. So then I interface the 2XL430. I'm going to call ID 18 and 19, and going to mount them right here. I don't have the pictures or whatever, but you just mount it there. So the horn goes on this side. Also, you can see that I also use an EF25F14 so that I can have some kind of frame so I can do the tilting part of the headpiece. Okay, once I have that, you can see a picture of it here, and then I found out that, oh, if I want to use that nice armor or that nice cover for the LED module, I have some huge problem. The epaulette here, shall we say, it runs all the way back, and you can see it interfere with my pan motion for the camera. So you see another picture of it where I had to cut off quite a bit. You can see I have cut the epaulette run all the way to the back edge of the of the robot. And so we see I had to remove it carefully, just chip it away carefully, take time to do it, but then it's done. So you can see it, there's no more interference on the right side, on the right shoulder of the robot now. But then it turned out it is on the left shoulder, there's a slight bump or interference too with the 5-pin connector, the one that controlling the LED module. But that luckily is just very small, so all you just pick up the edge of a knife and kind of scrape it a little bit. You can see here a little bit wider, and that does the job. Okay. Next, how do I connect the UART connector on the Pi to the CM-550? So on GPIO bus on the 4B, I'm going to be using the TTIS0 port on it. So that's where they are, the 3-wire. So I tap them out, come back, and they go into the UART port of the CM-550. You can see here. I have other video that show more detail and how to program all of that in there previously already. Next is about LiPo battery sharing. So I already have also give us details somewhere, but this is my latest version here. So normally the CM-550 LiPo battery goes here, it's connected here, and there's a kind of connected battery so that it can go extend it out a little bit, and then it goes into the CM-550 up here. So for my solution, I have to scrape the wire here a little bit, so I splice in 2 power cable line and goes to a barrel connector, and then this one is, of course, is a 12 volt to 5 volt converter. The output is USB-A here, so I buy USB-A cable that goes to USB-C, and that goes into the power input of the RPi4B. Just straightforward like that. So physically, when everything mounted all together, so you can see the RPi is I'm trying to mount it, in the middle, and so we keep balance left, right as much as possible. You see the UART connection coming down. You see the power from the LiPo battery, which is sitting right behind here, it coming out. This is the part where it splices out into the black connector that goes into the CM-550 in there somewhere, and then the barrel connector wiring is goes up here. It goes to the 12 volt to 5 volt converter here, coming out USB A, and it goes to the Pi USB C up here. So first thing to do first is, we put lots of weight in the back now. So to be sure, I go into the motion editor of task 3 and put it to basic pose. So you can see the picture here show that when it's in the basic pose, it's the robot itself kind of lean forward a little bit, so that before I can walk and go back. So that's the theoretical position of it, slightly forward. But you can see because of the weight, practically it's not off of its feet yet, but its weight is shifted in the back maybe half an inch. So therefore I haven't done it yet, but the upper rear up motion offset to some of the critical servo, especially the shall we say the ankle here, will need to be determined so that it can walk properly. So that part I haven't done yet. Hopefully in the next demonstration, I will show you that. Of course, I want to control the Max E2 from the RPi4B from now on. So the way it's set up is I use VNC viewer from the PC, and I can access through local Wi-Fi, and then I use code blocks to do programming in C. And so you can see the picture of a live image of the Max E2 looking at down at its feet. You see here, and then there's code there. So hopefully next time we'll get into more programming, and hopefully it will walk and do some autonomous search on its own.